everyone, it's Ms. Brooks with your Daily Dose of Math. Today we're going to be discussing Section 4 of Chapter 7, Factoring by GCF. Basically, factoring is undoing the multiplication process to figure out what polynomials you started with. So let's take a look at some basic examples by starting with GCF. So the best way to understand factoring is just to do a bunch of different examples. So in the first example under problem 1, we are going to factor 12x to the 5th plus 8x to the 4th minus 6x cubed. So in order to factor by GCF, what we are going to do is look to see what all of our terms in the problem have in common. So let's first look at the numbers. We have a 12, an 8, and a 6. We want to think of the highest number that can go in to 12, 8, and 6. So the best way to do this is list the factors of your smallest number. In this case, 6. What numbers can go into 6? Well, we have 1 and 6, or we have 2 and 3. Of those numbers, we want to see which one can go into the other numbers. And we try not to use 1 as a GCF, so I'm going to cross that one out. So we want to find the highest possibility, so I'm going to start with 6. 6 goes into 6, but 6 does not go into 8, so 6 would not be a GCF. Again, I'm looking for the highest number, so I'm going to check 3 next. 3 goes into 6, but 3 does not go into 8. So 3 is not my number. The last possibility, if this number has a GCF, would be 2. 2 goes into 6, 2 goes into 8, and 2 goes into 12. So my GCF for my numbers would be 2. So I'm going to write down a 2. Now, when there are also variables in the problem, I want to see if they have a variable in common between all of my terms. So my variables, I have x to the 5th, I have x to the 4th, and I have x to the 3rd. So all of my variables have an x. So with this 2, I'm also going to write an x. And when I take a variable GCF, I want to write down the smallest number variable that the term has. So in this case, if you look at our x's, the smallest number that any of the x's has is a 3. So I would say this is 2x to the 3rd as my GCF. Every factor that I have can be divided by 2. And every factor that I have has at least 3 x's. Once I have factored out 2x cubed, I'm going to divide everything that's left and write it in parentheses. So 12 divided by 2 is 6. X to the 5th, when I took out x to the 3rd, would leave me with x squared. Plus 8 divided by 2 is 4. There's x to the 4th, but I took 3 of them. That would leave me with just x. Minus 6 divided by 2 is 3. X to the 3rd we already took out, so I'm going to close this with a parenthesis. So when I factor, I should be able to multiply back my final answer and get what I originally started with. 2 times 6 is 12. X to the 3rd and x squared would make 5 x's total. Plus 2 times 4 is 8. X to the 3rd and x makes 4 x's total. Minus 2 times 3 is 6. And I just have x to the 3rd. So we are going to undo the multiplication process to see what did we start with to get the polynomial we are given. So let's take a look at the next problem, number 2. We want to factor 15x squared plus 18. So the first thing that I want to do is list my factors for my numbers. So I have 15 and 18. In order to figure out what number is going to go into 15 and 18, I should list my factors of the smallest number. So my factors of 15, I have 1 times 15 or 3 times 5. Again, we don't want to try to list 1 as one of our greatest common factors. And greatest common factor is the highest number that will go into both of these numbers. So I'm going to try 15 first. I know 15 goes into 15, but 15 doesn't go into 18, so that's not going to be my GCF. Next, I'll try 5, that's my highest. 5 goes into 15, but it does not go into 18, so I'm going to cross out the 5. That means my only possible choice is 3, but I do need to verify because not everything has a GCF. 3 goes into 15, and 3 goes into 18. So my GCF, the number I'm going to write down is 3. Next, I want to check variables. Do each of my terms have a variable? Well, the first one has x squared, but the second one doesn't have an x. So I will not have a variable as part of my GCF. I can only take the number 3. So using 3, I'm going to divide everything by it and write what is left inside parentheses. So 15 divided by 3 is 5, and we still have that x squared there. We've got to drop that down. Plus 18 divided by 3 is 6. Close the parentheses. And once you write your answer, multiply it back out to make sure it is what you started with. 3 times 5 is 15, and I wrote the x squared, plus 3 times 6 is 18. So since it multiplies back out to our original question, pretty positive we are correct. Let's keep going looking at a next example. Number 3, we're going to factor negative 18y to the 4th plus 6y cubed plus 24y squared. So the first thing that I'm going to do is try to find my GCF of my numbers. I have a negative 18, a 6, and a 24. So to find my GCF quickly, I want to write the factors of my smallest number. In this case, 6. 1 and 6 multiply to get 6, and so do 2 and 3. So again, we don't want a GCF of 1 because that doesn't actually let us take anything out of the problem. I'm going to start with my highest number. We're trying to find the highest number that goes into all of these. So let's see if 6 works. 6 goes into 18, 6 goes into 6, and 6 goes into 24. So I'm going to use 6 as my number for this problem. Now, this problem has something a little different than the other problems. Its first number started with a negative. Whenever your first number starts with a negative, you need to factor out the negative symbol. So this would actually be a negative 6 that we take out because the 18 started with negative. Once you have factored out your number, see if you can factor out a variable as well. Each one of these terms has a y in it. That means I can take the variable y and put it with the 6, and I want to take the smallest amount that any term had. In this case, the smallest amount was a 2. So each term had at least 2 y's in it. So my GCF is negative 6y squared. And now I'm going to divide everything by that and write what's left in parentheses. So negative 18 divided by negative 6 would be 3. Y to the fourth, but I already took 2, would leave me with y squared. 6 divided by negative 6 would be minus 1. And then y cubed, but I already took 2 of them, would leave me with y. So remember, I don't need to put minus 1y. I can just put minus y. Plus 24 divided by negative 6 would make minus 4. Y squared, we already have accounted for, so I'm going to close the parenthesis. So once you have your final answer, do multiply it back just to make sure it's what you started with. And notice when I multiply back, I'm not actually writing it down. I'm just making sure it would give me back the original. Negative 6 times 3 is negative 18. Y squared and y squared would be 4y's. Negative 6 and negative 1 would make positive 6. Y squared and y makes y cubed. Negative 6 and negative 4 makes positive 24, and the y squared was accounted for. So we can be pretty positive since it multiplies back, that is correct. So let's try one more problem together, number 4. We're going to factor negative 12x cubed plus 18x squared minus 27x. So the first thing I want to do is look at my numbers and see if they have anything in common. So we've got negative 12 as our smallest number, but I'm just really going to list the factors of 12. I'll worry about the negative later. So 12 would be 1 and 12, 2 and 6, 3 and 4. Again, I'm not going to worry if it has a GCF of 1 because factoring out a 1 is not going to change the original problem. I'm first going to start with the highest number and see if 12 goes into my other numbers. 12 doesn't go into 18, so that's out. Next, I'm going to try 6. 6 goes into 12, goes into 18, but not 27, so it's out. Next, I'm going to try 4. 4 goes into 12, but not 18, so it's out. Next, I'll try 3. 3 goes into 12, 3 goes into 18, and it goes into 27. So 3 is the number I'm going to use for my GCF. Next, I'm going to see if all the terms have a variable. In this case, they do. They all have an x. So I'm also going to put an x with the 3. I want to put the smallest exponent there was with that. In this case, that was a 1. So I'm just going to keep it as 3x. Now, remember, if the first term starts with a negative, on the outside, it needs to be a negative that you are factoring. So in this case, this problem started with negative 12. Our GCF needs to be a negative 3x. So whenever the first term's negative, put a negative on the outside. Otherwise, it's positive on the outside. So now that we have our full GCF, we're going to divide by that and write in parentheses what is left. Negative 12 divided by negative 3 is 4. It was x cubed, but we took one of those, so that would leave us with x squared. 18 divided by negative 3 is negative 6. X squared, but we took one, would leave us with x. Negative 27 divided by negative 3 plus 9. And it has an x, but we already took that, so I'm going to close the parenthesis. Again, once you have factored, multiply it back out and just make sure it is giving you what you started with. Negative 3 and 4 makes negative 12. X and x squared makes x cubed. Negative 3 and negative 6 makes 18. X and x makes x squared. Negative 3 and 9 makes negative 27. And I accounted for the x. So we can be positive that we are correct. So at this time, I would like you to try number 5 and number 6. I will write the answers on here so you can check and see if you got it correct. So if you factored number 5 correctly, you would have factored out an x, and that would have left you with x squared plus 5x minus 22. If you factor number 6 correctly, you would have factored out negative 4y squared, and that would have left you with 4 minus 7y squared plus 5y. This concludes our lesson on being able to factor by GCF. If you have any questions, please ask Miss Brooks. Otherwise, we'll catch you next time on your Daily Dose of Math with Miss Brooks.